1.1. Okay, Yuvraj, can you tell what's the question is?
So, spacecraft is moving relative to the Earth. Observing the Earth finds that according to a clock, 3601 sleep between 1 p.m. and 2 p.m.
Hmm.
on the spacecraft's clock. What
Right,
what is the spacecraft speed relative to the Earth?
right. Okay, so the question says that a spacecraft is moving relative to the Earth, right? Relative to the Earth, a spacecraft is moving. An observer on the Earth finds that according to her clock, 3601 second elapsed between 1 p.m. and 2 p.m. on the spacecraft. Right? So I'm making the figure here. Always one should try to make the figure here. So this is the spacecraft and one person is here on the Earth, right? So this is Earth and one person is here. Right? So a spacecraft is moving relative to the Earth and observer on the Earth finds that according to her own clock, 3601 second elapsed between 1 p.m. and 2 p.m. on the spacecraft's clock. Right? Okay.
Yes,
So
sir.
the time, so just see here between 1 p.m. and 2 p.m. How many second will be between 1 p.m. and 2 p.m.? That means 1 hour. Between 1 p.m. and 2 p.m. 1 hour. So how many seconds will be?
3600.
Yes, 3600 second, right?
3600.
3600 second. Between 1 p.m. and 2 p.m. Right? And it is given that a spacecraft is moving. An observer on the Earth finds that according to her clock, 3601 second elapsed between 1 p.m. and 2 p.m. on the spacecraft's clock. That means here this T naught, that is the proper time. Proper time is this 3600 second, right? And we have this moving time that is equal to 3601 second, right? So what is the speed of the spacecraft? This spacecraft is moving with velocity v. So that means your time dilation formula is this: T equal to T naught 1 minus v square by c square. Is it okay? Are you understanding?
Yes.
Yes, sir.
So from here you can find the velocity v, because t and t naught are given and c as usual 3 into 10 to the power 8 meter per second. So from here you can calculate what is v. Is it okay? On the same pattern you can
Yes,
have
sir.
numerical. On the same pattern you can have numerical question based on length contraction as well. Okay, so this is question number 1 here. So let me save this here. Now I'm going to next one. So what is next one? Next, second last question. Second last question, Yuvraj.
Sir, example number.
Second last question, just study that, read that.
An electron am not equal to 5.11 millielectron volt per c square, and a photon of mass 0 both have
Oh,
momentum.
no, so it's a different question actually. That's what I
It's
was
not in
telling that
order.
not in order, right? It's not in order. So just go through this example 1.5. Example 1.5. Just see where this example 1.5 is.
So find
Find
the
the
mass of an electron.
mass of an electron, right? Find the mass of an electron. So
Velocity is 6.5.
mass of the electron is given 9.1 into 10 to the power minus 31 kg, right? And this electron is moving with speed v equal to 0.99 c, right? So what is the mass of this electron? The electron which is moving, so when it moves, then its moving mass will be equal to, m will be equal to m naught 1 minus v square by c square. So just you have to put the values, right? There is no need to put the value of c here because c will get cancelled. 1 minus 0.99 c by c square, right? So c will get cancelled. So, right, it's a given. Answer is also given in the question. So 64 into 10 to the power minus 31 kg. So you can see that this m is almost 7 times of m naught, right? The mass of the electron has become 7 times of its rest mass if it is moving with velocity 0.99 c. Is it okay?
Yes, sir.
Okay. So come to the next question here. I am telling this from my own order actually. So example 1.6 now. Example 1.6.
A stationary body explodes into two fragments, each of rest
Right,
mass 1 kilogram, that moves apart at speed of 0.6 c relative to the original body.
right.
Find the rest mass of the original body.
Very good question this one is, right? What is here? There is one stationary mass, right? So suppose the mass of this is m naught, and this stationary mass after some time explodes into two fragments, right? It explodes into two fragments, and each of rest mass, that means the rest mass of this frag of both fragments, right? That is say one fragment, rest mass of one fragment is say m naught 1, right? And rest mass of the other fragment is say m naught 2, right? These two fragments move apart at speeds of 0.6 c. That means this one is moving with 0.6 c and this one is also moving at 0.6 c. So find the rest mass of the original body. That means what is m naught? Okay, so just see how this question should be solved. Initially, the original mass is at rest, so its total energy will be equal to rest energy, that is m naught c square. And this total energy before explosion will be equal to total energy of the fragments after explosion. After explosion, that means after explosion, the energy of the first fragment will be m1c square and the energy of the second fragment will be m2c square. And m1, that means moving mass of the first fragment, will be equal to its rest mass divided by 1 minus v square by c square. Of course, it will be v1 and m2c square. So m2 will be rest mass. This will be c square as well here, right? And this will be 1 minus v2 square by c square. So this is the energy, total energy before collision, sorry, before explosion in fact, and this one is the total energy after explosion, right? This is the total energy before explosion, and this one is after explosion. And according to the conservation of energy principle, the total energy before explosion will be equal to the total energy after explosion. Is it okay? Are you understanding this?
Yes, sir.
Yes, sir.
So the question has been asked in different formats in the examination. Right? Now remember that in classical mechanics, we solve such type of problems in a different way. There we calculate kinetic energy and potential energy, and then we find total mechanical energy. Right? So there in classical mechanics, so this is one question. Added in classical mechanics, you have conservation of mass and conservation of energy, right? Both are separate in classical mechanics. That means Newtonian mechanics, classical mechanics. But here in STR, we have what? We have only one, conservation of mass plus energy equivalence. Only one, that means this m1c square will be equal to m2c square. It will be like this, right? In STR, we cannot write m1 equal to m2. No, as you can see here, if you solve this problem, then m0 will come out to be, what is the answer? It's solved in the question. What is the answer? Yes, Madhuri, what is the answer here?
2.5
2.5 kg.
2.5 kg. And what is the rest mass of the fragments, both fragments together?
(1.0 kg).
That is mass of one fragment.
नो सर, मतलब रेस्ट मास है ईच फ्रेगमेंट का.
वही तो पूछ रहा हूं ना, टोटल फ्रैगमेंट्स का कितना हुआ? 2 kg हो गया ना, राइट? तो बिफोर एक्सप्लोजन कितना मास था? 2.5 kg. आफ्टर एक्सप्लोजन कितना रेस्ट मास हो गया? 2 kg, राइट? Are you understanding?
Yes, sir.
Before explosion, the rest mass of the body was 2.5 kg, and after explosion, the rest mass of the two fragments were 2 kg only. So there is a difference of 0.5 kg. ये 0.5 kg कहाँ गया?
सर एनर्जी.
एनर्जी में. कौन सी एनर्जी में? एक्सप्लोजन एनर्जी में. दैट मीन्स 0.5 kg into c square यही एनर्जी जो है वो आफ्टर एक्सप्लोजन यहां पर निकली है, राइट? दिस इज द एनर्जी ऑफ एक्सप्लोजन एंड this is the basis of atom bomb, hydrogen bomb, right? And this is the basis of the nuclear reaction. In nuclear reaction, the masses of the fragments are not conserved. Always there is a difference of mass, and this difference of mass is converted into energy. So in STR, we have conservation of mass energy. Mass plus energy, right? Not separately, not at all. Unlike classical mechanics. In classical mechanics, mass will be conserved, energy will be conserved as well. Here, there is only one conservation principle, that is conservation of mass plus energy. That will be conserved. And we have written, right? We have written this conservation of mass plus energy from, we have written this where? Here. Here. That energy conservation principle has been written here. Mass energy. Is it clear? Fine. Example 1.8. So let me save this one. Example 1.8. What is this?
An electron of mass 0.511 milli-electron volt.
Right.
I
And
see.
there are, fine. There is one electron here. So let me write one electron and one photon. Right? Electron is having mass of m naught is, that is 0.511 mega electron volt by c square, right? And photon rest mass will be 0, that we understood. Photon rest mass is 0, right? And both have momenta of, momenta is 2.000 mega electron volt by C, right? So find the total energy of each. Now, before I solve this, just consider why the mass, what is the unit of mass here for electron? Madhuri, what is the unit of mass that has been written here?
So mega electron volt.
By C square.
Yes,
This
sir.
is the unit, right?
Yes, sir.
How this unit has come? How to find the rest mass energy of an electron? Use this formula, E naught equal to m naught c square, right? Did you calculate, Yuvraj, yesterday? I told everybody to calculate the rest mass energy of electron, proton and neutron. Yuvraj, you had calculated in terms of joule, if I remember.
Yes, sir.
So did you convert that into mega electron volt? Madhuri, did you do?
No, sir.
Everybody should take these homework very positively. If you calculate, then you will get this 0.511 mega electron volt. This is for electron. So from here, what I can write? that the rest mass of an electron is equal to 0.511 mega electron volt by C square. Are you understanding? Is it clear?
Yes, sir. Yes, sir.
M naught C square is equal to 0.511 mega electron volt. So M naught will be 0.511 mega electron volt by C square. In STR, the unit of mass is written in terms of mega electron volt by C square. And momenta is written in terms of mega electron volt by C. Why? Because we have seen that this electron, this momentum, what is the relation between momentum and energy of a massless particle? What is that?
Sir, E equal to root over E naught square plus P square C square.
No, E naught will be for massless particle. E naught will be, what will be E naught? Goes to say that
Sir, E naught is the rest
unless you
energy.
revise the things, it will be difficult for you people. If I remember, this is like this, okay? This is true for general particle. For massless particle, E naught is equal to M naught C square, and that is 0 because rest mass of massless particle is 0. So for massless particles, sorry, this is not E naught here, right? This is not E naught, this is the total energy. Right, this is E, right? E equal to under root E naught square plus P square C square. Fine. So for massless particle, E naught is 0, so E is equal to Pc, right? So you can see here one can write momentum as energy by C. So in terms of unit, I can write momentum as mega electron volt by C. For E will be represented in terms of electron volt or mega electron volt or giga electron volt C. Right? So in STR, mass is represented in form of mega electron volt by C square, and momentum is expressed in terms of mega electron volt by C. Remember this. Are you getting the point here? Everybody has joined the class, still 2 students are not here. So is it clear?
Yes, sir.
Now you can find what will be the energy of each. So energy of a particle, remember I told you that for energy you have two formula. One that is related to kinetic energy and the other that is related to momentum. So depending on the context of the question, you have to use either of these two. Now in this question, what is given? Kinetic energy or momentum?
Momentum.
So this formula has to be used. So for electron, the energy will be equal to E naught square plus P square C square, right? So this will be equal to E naught square will be equal to M naught square C4 plus P square C square, and value of M naught is given, that is 0.511 mega electron volt by C square. So this is M naught and we have a square here. right? Then C4, and momentum of the electron is given 2.000 up to 3 decimal place given. So we will have to quote the answer also in terms of this. So P is equal to 2.000 mega electron volt by C. So that is square, and then we have C square. So you can see that C4 will cancel, and here C4 will cancel, and here C square will cancel, and I will be having mega electron volt square under square root sign. So finally we will be having mega electron volt. So in the question has been solved here, 2.064 mega electron volt. So this is for electron. And for photon, since m naught is 0, so E will be only equal to Pc. This is for photon, right? And this is for electron. Okay. And for photon, momentum is the same, 2.000 mega electron volt by C. So E equal to Pc. So C and C will get cancelled, and you will be getting 2.000 mega electron volt. Okay, so you can see that the electron is having slightly greater energy as compared to photon. Why this greater energy? Because there is a contribution from rest mass also. In case of photon, there is no contribution from rest mass because photon is a massless particle. Madhuri, is it clear?
Yes, sir.
Yuvraj?
Yes, sir.
Other students? Ashish?
Yes, sir.
Shashwat?
Yes, sir.
Suraj?
Yes, sir.
Suryan?
Yes, sir.
So this was the fourth question. Probably we have 5 questions, right? Isn't it?
एक
Yes,
और
sir.
है, सर, एक और है।
Last question. Last question is example 1.11. Okay. So Yuvraj, can you read the question?
Spacecraft Alpha is moving at 0.9 c with respect to the Earth. If spacecraft Beta is to pass Alpha, a relative speed of 0.50 c in the same direction, what
Right.
speed must Beta
Have with respect to the Earth. Very, very
Yes, sir.
conceptual question. This one is very, very conceptual. Right? We have 3 things here, right? A spacecraft Alpha, right? We have a spacecraft Alpha, then we have a spacecraft Beta, and both are moving with respect to Earth. Okay, so the situation is something like this. This is Earth here, right? And then there is one spacecraft Alpha, right? So say this is Alpha A, and there is one another spacecraft that is Beta. Always one should make the diagram, right? This is Beta and this is Alpha. Okay, so a spacecraft Alpha is moving at 0.90 c with respect to the Earth. If a spacecraft Beta is to pass Alpha at a relative speed of 0.50 c in the same direction, what speed must Beta have with respect to the Earth? This is the question. So now, can you apply the frame of reference here? We suppose we take this edge, Earth edge. This is our Earth. So this is S frame of reference, and say this one is S prime, and this Beta we are watching from both S and S prime. Right? We are watching Beta from both S and S prime. Question says a spacecraft Alpha is moving at 0.90 c with respect to the Earth. Right? Alpha is moving with respect to the Earth. That means the frame S prime is moving with respect to the frame S. Right? Yuras?
Yes, sir.
So in our notation, what is the velocity of S prime with respect to S? What is that? V. Right? We have taken the relative velocity of S and S prime as V.
Yes, sir.
Right? So V is given here, 0.90 c. Next line is, if a spacecraft beta is to pass alpha at a relative speed, that means the speed of beta with respect to alpha, that is given. That is 0.50 c. So what is this? What is this in terms of our notation? This is ux prime, velocity of something with respect to s prime. And it is telling that it is moving at a relative speed in the same direction. In the same day, that means both v as well as ux prime have the same direction. Okay, so we can take both as, say, both are moving, say, in the direction of x prime. Okay, so we can take both as plus plus. And what we have to find? What speed must beta have with respect to the Earth? What is the speed of beta with respect to Earth? That means with respect to s. And with respect to s, the velocity of anything is ux in terms of our notation. Is it clear?
Yes, sir.
So ux will be, just recall that, inverse transformation for velocities. Inverse Lorentz transformation, v by c square ux prime. So now you have to put the values of both, and it is given, it has been solved, and it has come out to be 0.97 c. Now if I use Galilean transformation, that means Newtonian mechanics, then ux will be equal to what? Shashwat, what will be ux under Galilean transformation? Shashwat? Shashwat? Very sorry to see such type of indiscipline. Suryan?
Sir, ux dash plus v.
Ux prime plus v,
Yes, sir.
right? This will be ux prime plus v, and ux prime is given as 0.50 c and v is 0.90 c. So this will come out to be 1.40 c. What you can conclude here, Yuras, for ux equal to 1.40 c? According to Galilean transformation, the velocity of beta, spacecraft beta with respect to Earth is 1.40 c. So what can you conclude here?
Sir, the speed is not changing with motion of the plane.
No, 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 no. Very important conclusion. Madhuri, can you tell here? Madhuri,
Yes, sir.
can you tell? Anything that you can tell here? Suraj?
Yes, sir.
Can you conclude here for ux equal to 1.40c? Ashish?
Yes, sir.
Can you conclude something here for this value ux equal to 1.40c?
No, sir.
Shashwat? Why you should not tell here this
सर
ux?
वो उस इस सर वो एक इंस्टेंट के लिए बस वो स्पीड आ रहा है.
No. What you get here, ux is greater than c. This is 1.40c. That means the spacecraft beta has the velocity which is greater than the speed of light in free space, which is not possible. Right? STR puts a moratorium on the speed of anything. It cannot be equal to the speed of light. Any material particle has to move with a speed less than the speed of light in free space. Right? But this Newtonian mechanics doesn't put any restriction. Any material body can have anything, any velocity. Okay, so why this Newtonian mechanics fails here? It is because both spacecraft alpha and beta have a speed which is comparable to the speed of light in free space. So you cannot use this. No way. Newtonian mechanics fails here. You have to use STR. And when you use STR, then you get ux equal to 0.97c, which is definitely less than c. Is it okay? Madhuri, is it okay?
सर एक बार फिर से बता दीजिएगा.
See, the conclusion, a very important conclusion from STR is that nothing can move with a speed equal to the speed of light in free space. Nothing. But as far as Newtonian mechanics is concerned, there is no restriction. Okay? And if we apply Newtonian mechanics here, then we are getting that a spacecraft beta is moving with a speed which is greater than the speed of light in free space. This is not possible. Right? So here we cannot apply Galilean transformation. है ना, मैंने डायरेक्टली सबसे पहले मैंने इसको लॉरेंस ट्रांसफॉर्मेशन से निकाला 0.97 से. पहले मुझे क्या करना चाहिए था? हाँ, आई शुड हैव स्टार्टेड फ्रॉम गैलीलियन ट्रांसफॉर्मेशन. राइट? यही होना चाहिए ना. पहले जो हम लोग हैबिचुएटेड है, कॉमन सेंस जो हम लोग बोल रहे हैं कि कॉमन सेंस इज न्यूटोनियन मैकेनिक्स. So if we apply Newtonian mechanics, then we get ux equal to 1.40c, which is not possible at all. Because STR puts a limit on the speed of anything. So we have to use STR here. And if we use STR, then ux is definitely less than c. Yuras, got the point?
Yes, sir.
Okay, so 5 questions I have solved here, but I will appreciate all of you that you should try to solve some more problem here. So how many I have? 1, 2, 3, 4, 5. Okay, fine. So I have tried my level best to complete this STR here. As I told that I generally take almost 15 classes to cover this portion, but due to lack of time, it is not possible for me, and it is not possible for you as well, right? Because we are nearing the end of this semester here. Fine, but I will be taking extra classes here on tomorrow. I will be having class definitely at 12 o'clock as usual. Okay, but I'm not sure whether I will be taking at 12 or not because our Vice Chancellor is coming today. Okay, so probably there will be a meeting with all faculty members tomorrow. And at what time it has not been disclosed at all at this moment. So I don't know if the meeting is scheduled at different time, then I will be taking the class at 12. Otherwise, I will announce. I will send the message to all of you. But on Friday we have 9 o'clock class, and on Saturday as well as on Sunday. On both days we will be having class. We can have at say 9 o'clock on Saturday, Sunday. Is it possible? Do you have any other class on Saturday, Sunday, Yuras?
Sir, on Saturday there is class and exam as well.
Timing?
Sir, time is not declared yet for maths examination. And
Which
we have
which
PPS
examination?
class,
Which examination?
maths examination.
Okay, and PPS class at what time?
11:50 from I think.
11 o'clock. So now from 9 o'clock we can have. Right, Madhuri?
Yes, sir.
Suraj?
Yes, sir.
Suryan?
Yes, sir.
Shashwat? Shashwat, are you here? Ashish?
Yes, sir.
So we will be having class on Saturday and Sunday at 9 o'clock. So I request all of you that you should not put any other class on that time actually. If any other faculty member is interested in taking extra class, then you should give any other time, not 9 o'clock.
Okay, sir.
Okay. So what class we have after this?
Maths.
Okay, fine, fine. So you can leave the class now.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.